Okay, today we're going to look at different types of algebraic graph, and I'm going to break it up into 5 sections: linear graphs, quadratic graphs, cubic graphs, reciprocal graphs, and exponential graphs. And we're going to look at the different shapes that each of these graphs take. The first one we'll start with is linear graphs, and this is straight lines. So we've got a few different types. We've got the vertical type of straight line, which are x equals type, for example x equals 4. We've got the horizontal types, which are y equals type, so that could be y equals 3 if it cuts through 3. Got another couple of special cases. We've got y equals x, which is a diagonal line that way, and y equals negative x, which is a diagonal line with a negative gradient. These are special cases. What we're really interested in is any straight line which can be written in the form y equals mx plus c, where m is the gradient of the straight line and c is the y-intercept. So that's linear graphs can be represented by y equals mx plus c, where this is a x without a power. Second type we're going to look at are quadratic graphs, and they are a U-shaped graph. All quadratic graphs are based on the graph y equals x squared. Quadratic means that the x's squared is the highest power. So they're all based on y equals x squared. We can have an n-shaped graph, which would be a negative quadratic, and basically this U-shape can move anywhere along the axes. Key points here would be the y-intercept, the two roots, and the vertex of the graph, which is a line of symmetry. The third type of graph is a cubic graph, and these are all based on the graph y equals x cubed, which looks like this. So a cubic will start in one direction and end in the other. A negative cubic graph will look similar but the other way around, starting very high and decreasing. Quite often cubic graphs will be more exaggerated, so they may go up and down like this and have two obvious peaks. Next we have reciprocal graphs, and these are all based on y equals 1 over x. And as you can see with this, as the value of x gets larger, the value of y will get smaller. So you'll end up with a graph which looks like this. As x gets very big, y will get very small. X cannot be 0 because 1 divided by 0 of undefined is undefined. So what we get here is we get an asymptote here and here. An asymptote is a line towards which the graph tends but will never reach. If x is negative, we have a repeat of the graph in this corner here. So all reciprocal graphs are based on this one, have this similar shape. If this graph is transformed in some way, you can end up with the asymptotes being in a different position, but the basic shape of the graph will remain the same. Our final type of graph is exponential graphs, and my first example here would be y equals 2 to the power of x. So this is the first time where x is actually the power, and you can imagine this increases very quickly because we're doubling every time. So the graph will look like this, and it will increase very quickly, exponentially. All our exponential graphs are based on this shape. The steepness and the position may change slightly. This is a key point on an exponential graph because this is when x equals 0, and as we know, anything raised to the power of 0 is 1. So unless there's something else going on, this point here will always be 1. There is an asymptote in this graph too. So the x-axis here is an asymptote as x becomes negative.